Okay. So what we did last time, guys, I taught how can you make a flashing LED using assembly, and that's what I explained here. Simply, what I said last time, guys. Number one, we need to do initialization. Is that I already explained what this initialization means, and this should be done only one time. As you see here, this part is going to be executed. Let me maximize the slides. Okay. Just give me 1 second. I think I need to hide this one. Yes. Okay. So this part here, guys, is the initialization. This should be done only one time, okay, in the beginning of the program. That's what I taught. Also, what I taught here, I created infinite loop. Oops, sorry, I'm sorry. That's what I'm going to explain now, but let me go back to the assembly part. Yeah, this is the assembly part. Okay, so in assembly, it's exactly the same thing. That's what I want to say. So the first part here, guys, is initialization. I already explained it many times. I'm not going to explain it again. If you have any question, you can ask me. You need to every port you are going to use, you have to configure this port output or input. In this program, all of them are output. Also, some BG you have to enable LEDs by writing 0 here, and also you have to make sure PP0 to PP3 you have to write 1 in order to disable the 7th segment. Okay, guys, so this is the first part, and then I created here is infinite loop. This is infinite loop. Okay, and in this loop, I'm gonna turn the LED on, I'm gonna wait 1 second, I'm gonna turn it off, I'm gonna wait 1 second, and so on. Infinite loop. Okay, now I'm gonna teach how can we do the same thing in C, and it's actually exactly the same structure. The only difference is that I'm gonna just use C commands. This is the only difference. Okay, so if we come here, guys, to the C language, let me erase what I did here. Okay. So as I told you, in C language we have a main function. Okay, every C language program should have, it must to have a main function. Okay, you may add more function subroutines or function, or may not, but at least it should have a main function, as you know. Okay, here in the beginning, this is again initialization. This is exactly similar to the initialization I did before. Look what I did here. Always we are going to use this, you are going to call this function. This function actually is going to initialize the system so that the frequency is going to work on 24 megahertz frequency. Okay, this is number one. Number two, you can use DDRB. You don't need to define them because it's already defined when in this project we select what kind of processor we have. Okay, so so all of them are already, and we already also as well we include this file here. So it's already defined, so you don't need to define them. It's already defined here. Okay, so you are going to use DDRB, data direction register B equal FF. Okay, guys, what this one means, similar to what we did in assembly, that means port B is output, because in the direction register I'm gonna write 1 1 1 1 1 1 1, which means it's output. Okay, all the pins are output. Okay, here also I'm gonna configure port J. Okay, actually, you know, I don't want to be confused, guys. I'm just interested in BG1. Is that right? I'm just interested in BG1. Okay, so I can configure only BG1. That's okay. Or if it doesn't matter for you, I'm gonna configure the whole board DDRG, and that's what I did here. Okay, so if it's not gonna make a difference because I'm not gonna use the other pins on port J, so it's not gonna impact because this is a simple program. You understand what I'm saying? So what I'm saying, guys, I'm gonna use only one pin. Okay, so you can configure only this pin if you want, or you can configure the whole port if it doesn't matter for you. That's what I did here because I'm not gonna use the other pins on this port. Okay, same thing here for port P. Remember, and that's what I'm gonna explain later in details. Port P, I'm gonna use PP0 until PP3 to enable. This one is gonna enable 1 7 segment, another 7 segment, so we have 4 7 segment. Okay, so here I have to configure port P as output. Okay, and then here I'm gonna write 0 0 in port J, and here I'm gonna write FF on port P because if you want to disable the 7 segment, you have to write 1 1 1 1 1 here. Okay, so this part is initialization. It is exactly similar to what we this assembly code I taught before, but the only difference is that I'm just using C commands. Okay, and now I'm gonna create infinite loop exactly similar to what we did before. Look what I'm doing here in this infinite loop. What I'm doing in the loop here, guys. Number one, I'm gonna turn, do you remember this one? LED on. This function you have to tell me, give me a number from 0 to 7 to tell me which LED you wanna turn on. Is that okay? So this one is called LED on. And then I'm gonna write number 0. So this command is gonna turn LED number 0 on. Is a LED connected to bit 0 or connected to B0, okay? So this one is going to turn it on, and then I'm going to call a function. This function is called ms_delay. This function is going to make a delay in millisecond, and I have to send this number. So if I send here this number, guys, 1000, that means this function is going to make 1000 millisecond delay. Is that okay? Which is 1 second. So here I'm gonna turn one LED on. Here I'm gonna wait 1 second, and then I'm gonna turn the LED off. Then I'm gonna wait 1 second. Okay, so this is one iteration. So in one iteration, I'm gonna turn on 5 volt for 1 second, and then I'm gonna turn off, which is 0 volt for 1 second, and so on. This is one iteration. I'm gonna keep repeating this iteration over and over again. Okay, so here in this slide, guys, I summarize the subroutines we have. So we have ms_delay, and we have to put a number here. This one is gonna make a delay in millisecond. Another one here is called us_delay. This one is gonna make a delay in microsecond. Also, we have LED on, we have LED off. That's what I explained. Okay, guys. If you have any question, unmute your mic and ask me. Okay, there is no penalty to do that. So feel free to do that. Okay, it's already tough teaching environment. Online for sure, it's not as effective as in person. But yeah, so if you need to ask any question, just unmute your mic and interrupt me. Okay, it's okay to interrupt me. Okay. Any question here, guys? Okay, so yeah, so here this is exactly the same program, but I just wanna teach another way. Okay, you know, I'm teaching programming, so I should not be very limited in my teaching, and I teach only one way. Okay, so I have to show you different ways. Okay, so if I go back, what I want to teach you guys here is, let me erase here. Okay, I told you here, I told you guys here we have to do some initialization, and the way I did here the initialization, it's more like low level. This is a low level way. Low level, why? Because I have to know which port, so it's too much details. You got what I'm saying? There is another way which is like high level. High level, again, I already taught that in chapter 1. Low level means it's very close to the hardware, so you have to know that we have a port B, port J. This is low level. Okay, it's okay, it's totally fine, but this is more suitable for assembly programs than C. But anyway, so it's okay to do this way. I'm okay. But what I want to tell you is, one of the main advantages of C language is that C language can hide the details. Okay, so what I want to say here, guys, is the following. There is another way to do this initialization using functions. Is that okay? Look at this function here. So we have a function, for example, it's called here 7 or segment 7 or 7 segment disable. So this function is going to disable the 7 segment. Okay, and we have another one, LED enable. Okay, these two functions are actually, if you go inside the program and see what's inside this function, you will see this initialization is written there. Okay, so if you want to use LEDs, you can simply just use this one, LED enable, and that's fine, because inside this function, you know what I'm writing here in this inside this one. everything related to LEDs. This one, okay, and this one. So these three instructions are already here in this function. Is that okay? So you can just write this function, okay? For the 7 segment, these 2 instructions are already here inside here, okay, guys? So it's up to you. If you like to use this way, I'm okay. If you want to use function, it's okay. But you should understand what is what is the main difference between the 2 styles. This is one style. This is another style. This style is more like low level. This style is like high level. High level means you are very far from the hardware. You don't need to know what port is. You don't know. You don't need. If you just want to use the LEDs, just enable LEDs and just use them. You understand what I'm saying? Okay. Same thing, guys. This is the program I have just taught right now, but I just also want to show you another way. Okay. So here I can say LED on, and then I can put 0. In the previous program, I put 0. Here I put 1. Doesn't matter. Okay. So here I want to turn LED number 1 on. Okay, that's the same program I taught before. Okay, but I just want to show you, instead of using this instruction LED on, you can do this way. It's exactly same thing. Whatever you like is okay. Okay, so what this port B equal port B XOR 02. Remember, I taught it multiple times, guys. If you want to set some bits, the way you can set some bits is using OR, and that's what I did here. So this one is gonna set 1 bit. Okay, and that's exactly what this function is doing. Okay, same thing here. If you want to clear, if you look at this one, guys, here, if you want to clear 1 bit, you can use this one. So this one is okay. Okay, and this one also is okay. Whatever you think it's but whatever you like is okay. Both of them are going to do exactly same thing. But what I want to tell you is that this one, and you have to be careful here. This function is made. Okay, so this function is made for port B. So this one works only for port B. However, this style or this way, it can work for any port. You understand what I'm saying? So I can say PTT if it is port T, and that's what we're gonna do right now. Okay, in one program right now, I can say BTT and so on. So this is like more generic, but this function only for LEDs, which is port B. Okay, guys. Any question? Any question, guys? Okay. Now I'm gonna move to this program here. Yeah. So this program, I wanna create something like serial communication. I'm gonna tell you what I mean by serial communication. Okay. Serial communication, guys, means okay. Serial communication means if this is a microcontroller, guys, and I have 1 pin, okay, maybe this microcontroller is communicating with another microcontroller. This is sender, and we have a receiver. Okay. Okay. So here in this sender, you are going to send to your data serial. Serial means, so if you look at the time, you can see it is, for example, here you can output 1 and then 0, 1, 0, and so on. And all this data has to come to here. So it's only 1 pin. This pin every certain time, for example, every 10 millisecond. So if I can do it this way. So here, the difference here is 10, for example, just any number, 10 millisecond. So this is my data. The pin is going to be high. So here I'm sending 1 to the other side. Then I'm sending 0. Then I'm sending 0. I'm sending 1. Okay, I'm sending 0. So this can be like an information. You send some message serially. We use serial communication all the time, like USB and COM. Okay, so we use the serial communication all the time. Okay, so I want to do something like that, and this is a program. I'm going to do it in this program. So what I want to do here in this program, and I'm going to teach you this program in both assembly and C. So what I want to do here, guys, in this program, this is the information. Let me come here. Okay, so this is the information I want to send on PT0. Okay, on PT0 I want to send this information here. Okay, so I want to send 01001111. This is a message. Okay, but so this is the information I want to send on this pin. That means if you connect this pin on the scope, that's exactly what you have to see. Okay, but if I generate this signal only one time and you connect to the scope, you are not going to be able to see it. Okay, because it's going to be very quick. Okay, so the way I'm going to do here in this program, I'm going to repeat it. So this just, I'm repeating it just because I want to see it on the scope. This is the only reason. You got what I'm saying? So this is a message, and I want to repeat the same pattern again. Okay, so if you that's what I did. This is my picture. Okay, so I display it on the scope, and that's what I found here. If you can see here, guys, it's let me go back. It is 0100. This is 0100. Okay, and then what? And 4 ones, 1111. Okay, and you can see this part here, guys, is repeated again, 0, okay, 10011. So just I repeat it so that I can see it on the scope. Okay, guys, any question? You understand what I want to make? So I want to write a program so that this program, like a serial communication, only one pin, this pin should like display a signal like this one. For sure you can see there is some delay here, sometime here. Whatever the delay, it can be 10 millisecond, 20 millisecond, whatever it is. Same thing here, there is some delay here. So here, okay, so I have to keep the bit on the pin for a certain time. Okay, okay. Now I'm gonna teach you how can you do something like that in assembly, and then I'm gonna teach how can we do the same thing in C. Okay. Let's start. Maybe it's a better idea. Yeah, let me try. I'm gonna start with C first, okay? Because C is compact, okay? We don't write too many instructions. Once you understand C, it would be easy to go for assembly, okay? So let's start with C. How can we do something like that in C, okay? So here in C, I have two ideas, okay? I'm gonna explain. I think, no, I don't think it's, oh, sorry, it's only one idea. Okay, so we have here only one program, so I'm gonna teach how we're gonna do it, okay? Look, the idea here, guys, okay? This is the pattern I wanna generate. This is the data. This is the serial data. So I have to generate this data this way, right? So from left to right. So I have to output 1 first, and then I have to output, sorry, 0, 1, and then 0, 0, 1, 1, 1, 1. Then I have to repeat again. That's what I want to do. Is that okay? Okay. How can we do that? How can we do that? I'm going to tell you how. This is a byte pattern. This one pattern. This is the idea. Number one, I'm gonna look at this bit. Very simple. I'm gonna check this bit. If this bit is 0, so BT5 should equal 0. If this bit is 1, so BT5 should equal 1. Very easy, right? So all what I have to do, guys, number one, I have to check. I have to check if this bit is 1 or 0. If it is 0, I'm gonna output 0. If it is 1, I'm gonna output 1. Is that okay? Then what? Then I have to wait some time, because that's exactly what I'm doing here. After I output some value, I have to wait some time. Yes. And then I have to wait some time, and then I have to move to the next bit. Is that okay? So I have to move to next one. I have to repeat the same thing on this bit. I have to check the bit. If it is 0, I'm gonna output 0. If it is 1, I'm gonna output 1. Is that okay? And then I'm gonna wait another time. I have to go all the way until the end. Once I come to the end, I have to come back to the beginning again, because I wanna keep generating the same pattern. Okay. So this is the main idea. So now the question is that, or there are two things here. If you understand them, it's gonna make everything very easy. Number one. So technically, I need to do two things, guys. Number one, I need to check the bit if it is 0 or 1. This is number one. Number two, if it is 0, I have to output 0. If it is 1, I have to output 1. So how can you output 0, or how can you output 1? So let's start with the second part first. How can you output 0? How can you output 1? That's very easy, and I taught it many times. So for example, look at this command to understand how can you output 0. Okay, if you want to output 0, guys, you actually, I'm going to use AND operation. Okay, as I taught it many times, right? The bit you want to clear, I have to put 0. The bit you don't want to clear, you have to put once. I taught it in chapter 2. I put it. So this is the command, and you can use the same command for any port, just to change the port here. So I'm using PTT because this is port T. Okay, and here, actually, I think I said it's here. I'm gonna output the result on PT0, right? Because here it's here, the first bit on port T, PT0. Okay. Okay, this is how can you output 0 if you need to output 0. Now, if you want to output 1, how can you output 1? So that's what I explained many times as well. Look at this one here. Okay, let me make some erase. Is there a way to erase every erase all link? Ah, good. So here, this is how can you output 1 using OR. That's what I explained as well. Okay, so now this is what I explained now. How can you output 0? How can you output 1? Okay, the second question is that how can you check the bits if this bit are 1 or 0? Okay, I explained it again before. In order to check, the way you have to do it, I'm going to use AND operation. Okay, how? I'm going to tell you how. So what I'm going to do, this is pattern, this pattern here. Okay, and then I'm gonna use another variable. I'm gonna call it mask. I'm gonna tell you what this one is doing. Okay, so then I have another one. I'm gonna call it mask. As you see here, guys, the initial value for mask is it's 1 0 0 0 0 0 0 everywhere. Is that okay? Why? Because I want to check this bit. Okay, and then I'm gonna do AND operation. That's what I explained before, guys. Okay, because these are zeros. So here the result, I'm sure the result is going to be 0 0 0 0. Is that okay? And now here this is bit 7. Okay, and bit 7 and so should be bit 7. Okay, so that's exactly what I'm going to do. I'm going to do AND operation between this pattern and between the mask. Is that okay? And now I'm going to look at the result, the whole result. If the whole result is 0, what it means? It means bit 7 was 0. That's exactly what I did. Look here, guys. So this is pattern, this is AND operation, and this is mask. Okay. And what I'm doing here, I'm gonna check one bit, and if the result is 0, if this byte, the result of this AND operation is 0, it means I'm gonna output 0. Otherwise, I have to output 1. Okay, guys, you should understand this one. I already explained in chapter 2 how can you check some bits. Okay, but here I just use C language. Okay, but it's the same idea. It's just logic N. Okay, guys. So now, so I think now the idea is very clear, very interesting, very easy. But there is another issue here. This is in one iteration. In one iteration, I have to work in one bit. What about the next iteration? Next iteration, I have to repeat the same thing, but I have to work on this bit. The third iteration, I have to be here. Fourth iteration, I have to be here. Fifth iteration, I have to be here. So every iteration, I have to try different bits, different bit, right? I have to check different bit. Okay, how can you do that? Okay, that's what I'm going to explain now. It's very easy. So the way I'm going to do it is, can you see mask here, guys? Mask, in the very beginning, the one is here because I want to check this bit. Is that okay? Then I'm going to shift mask. So now this is in iteration 1. That's okay. In iteration 2, mask is going to become 0, 1, 0, 0, 0, 0, 0. By this way, I'm going to check this bit. This is in iteration 2. Okay, same thing in it. This is iteration 2. Iteration 3, same thing. I'm going to shift it again. So 0, 0, 1, so that I can check this bit and so on. Is that clear, guys? So in every iteration, so let me say this way. In the very beginning, mask, the one should be here in the mask because I'm gonna check this bit, okay? And then every iteration I'm gonna shift mask by 1 so that I can check this one, check this one, check this one. Where it is here, that's exactly what I'm doing here, okay? Look here, guys. So this part here, this part, you actually check one bit, okay? And then you output 0 or 1. based on this bit is 0, I'm gonna output 0, I'm gonna output 1. Is that okay? And then, as I told you guys, I have to wait some time. I have to wait some time, for example, 10 milliseconds, whatever it is, okay? And then, now I wanna prepare, I'm done. By the way, by this way, I'm done for 1 bit. Now, I wanna prepare for next iteration. So the way I have to prepare for next iteration is that this mask, I'm gonna shift the mask. Shift the mask, so that if right now I'm checking this bit, so next iteration I'm gonna be here. So shift it. Okay, guys, is that okay? Is that everything? No. What's missing? What missing is that if I shift mask all the way to here and I shift it more, and now mask is 0, 0, 0, 0. So after each iteration, mask should be 0, 0, 0. You understand this, guys? So let me tell you exactly how mask should look like. It's 1, 0, 0, 0, 0, 0. This is the first iteration. Next iteration, 1, 0, 0, 0, 0. Okay. Next one, 1, 0, 0, 0. Okay. And then all the way until the 1 is here. All right. And then when I shift this mask, so it's gonna become 0, 0, 0. Okay. So that means I already displayed 8 bits. So what should I do now? I have to repeat again. So I have to come to here again. Okay, where it is here in this code, it's here. If you look here. This part here, guys. Oops. Okay, it is here. Yeah, look here, guys. So here, if mask equals 0, so that means I shifted all the way to the end. So now mask should equal initial value again. Is that okay? So let me summarize what I said before I see if you have questions or not. Okay, I think that's very easy. So so number 1, guys, here I have 2 variables. One is called pattern, and this is the pattern I want to generate. Is that okay? This number 1. Number 2, I'm going to use something what's called mask. This mask should help me to check 1 bit in each iteration. Okay, so I'm going to start with 1, 0, 0, 0. This is the initial value for mask. Okay, and then here, for sure, I don't need to tell you, if you want to use any port, you cannot. Okay, that's what I mentioned multiple times. You cannot use any port if you cannot use any port if you don't configure it input or output, right? So you have to do this configuration 1 time. Is that okay? And then we have infinite loop here, infinite loop. All here in this part, as I said, I'm gonna check 1 bit. Okay, if the bit is 0, I'm gonna output 0. If the bit is 1, I'm gonna output 1. I'm done. Okay, and then I have to wait 10 milliseconds, because when I output some value, I have to wait some time, so that the receiver can take, this is a communication, so the receiver has to take this value. Okay, it cannot be too quick. If it is too quick, the other side may not be able to absorb the data. So this is, if you look at any communication protocol, there should be some delay here. Okay, so I have to wait some time, and then we are gonna here. So now here I'm done with 1 bit. Now I have to prepare for next iteration, because I'm gonna come back here. Okay, to prepare for next iteration, number 1, I'm gonna shift mask to the right. Okay, so that I can check next bit next time. Also, I have to make sure if I shifted mask all the way and now it is 0, 0, 0, 0, so I have to come back again, and that's what I did here. Okay, guys, any questions? If you have any question, unmute your mic. And okay. Okay, let me tell you now how can we do the same thing using assembly, but I'm gonna, to check some bits, I'm gonna use a little bit different idea. So I'm not gonna use mask. I'm gonna tell you what I'm gonna do now. Okay, so it's somehow different idea. Okay, but it works. Again, I like to programming. In programming, we should learn different ways. Okay, so this is the same program. How can we do it in assembly? Okay, so in assembly here, number 1, this is the beginning of your program. Number 1, you have to configure PT0. You have to configure it output, right? So you have to use DDRT. Anyone has a problem here, guys? We are gonna do it all the time. This is a configuration. Is that okay? This is number 1. Okay. Number 2. Okay, and then I have P, variable called P here. This variable P should have the pattern, this pattern. Okay, so this is like pattern. the variable pattern I used in C language. Okay, so now this is just a configuration. My program is here. This is loop, this is branch loop. So I'm gonna create infinite loop here. Infinite loop. Okay, guys. So I'm gonna have infinite loop here. So this, yeah, sure.
I have a question.
Sure.
So loop, high, and next. Why don't they have a colon after them?
Sorry, see your column after next. What's the question?
Why doesn't it have a colon after it?
Okay, that's a very good question. Okay. Okay, I'm gonna answer this question, but let me go to C language. Okay, I know it is a little bit confusing. Look here, guys. Thanks for this question. In C language, you have to put semicolon. So sorry, you are okay. Anyway, let me say it here. In C language, you have to put semicolon at the end, right? Because this is the end. But here you have this semicolon. You don't need to put semicolon here.
Oh.
You got what I'm saying? C language, every instruction you have to end it with semicolon in C language. This semicolon here is just for command. It's like backslash in C language because I'm writing the command, but you don't need to put it. Is that okay? Does that answer your question or not yet? You understand what I'm saying?
So, not like semicolons, but like colon. Like you.
What is the colon? I don't see in. Yeah, I got you. I got your question.
Referring to the colon.
No, I got your. Yeah, I got your question. It's not this colon. This colon. Sorry, I misunderstood your question. I thought you are confused here. But anyway, so it's okay if you put. I think good order is gonna. It's the same thing. So the question, guys, is now if you have a label like this one, okay? Usually you put colon here, right? You don't need to. You don't need to. Okay. This is my answer. If you put colon or not, I think good order is gonna accept it. Okay.
Okay.
Okay. Now, so here, guys, I told you I have infinite loop here. This is the infinite loop, okay? And this is the infinite loop here. In this infinite loop, I'm gonna do the same thing I did in the C language. I have to check bit by bit, and if the bit is 1, I'm gonna output 1. If the bit is 0, I'm gonna output 0. Exactly same thing. And then I'm gonna wait some time and so on. Exactly same thing. But here, I'm gonna use somehow different way to check. I'm gonna use different way to check. Okay, how you are gonna do it? Different from mask? So what I did here, yes, different from mask, just different idea. Okay, what you are gonna do here, I'm gonna tell you what I'm gonna do. Look here, guys. If this is P, variable P, okay, pattern, and then if you shift it to the left, what's gonna happen? What's gonna happen? This bit, which is bit 7, is gonna go to the carry. You remember? Yes. So that's exactly what I'm gonna do. What I'm gonna do, I'm not gonna use mask, just different idea. What I'm gonna do, I'm gonna shift to the left. When I shift to the left, this bit is gonna go to the carry. And then I'm gonna check if the carry is 1 or 0. Is that okay? If the carry is 1, I'm gonna output 1. If the carry is 0, I'm gonna output 0. Okay? So show me where you did that. Yeah. So number 1, look here, guys. Shift. So I'm gonna shift it here one time. When I shift, I'm gonna take 1 bit here. Okay. So every time I shift, I'm gonna take 1 bit. So that means in the first shift, in first iteration, this guy is gonna visit the carry. Next iteration, this guy is gonna go to the carry, and then this one is gonna go to the carry, and so on, because they are shifted. Okay. And then now look here, guys. After I shift, I'm gonna say branch if carry is set. If the carry is set, if the carry is high, go to a place called high. Otherwise, if I come here, that means carry equals 0. So I have to output 0. Is that okay? So let me show you how the program works here. Number 1, shift. Number 2, if the carry equal 1, come here. If the carry equal 0, come here. If the carry equal 1, so I have to output 1. Is that okay? If the carry equals 0, so I have to output 0. Bit clear, bit set and bit clear. Okay, guys. And then after that, I'm gonna come to here to next, and next here you can put some delay. I didn't put here a delay, but you can put it. So you can put here a delay. You can put some delay here if you want. Okay. I didn't teach you 2 instructions. I'm gonna teach them now. This instruction I teach it. I didn't teach why you need these two instructions, but forget them now. Forget these two instructions now. Let me know if you have any question about the logic about what I did here. Number one, shift. When I shift, one bit is gonna go to the carry, and then I'm gonna look at the carry. If the carry is gonna high, I'm gonna come to here so that I output 1. If the carry is 0, I'm gonna come here to output 0, and then I'm gonna branch to next. When I come to next, I'm gonna put a delay here, and then I'm gonna come back to do it again. Any question? I didn't teach two instructions. I'm gonna teach them now, but until now, any questions? Okay. So now, what's the problem now? If why I need to add these two instructions here, this one and this one. I'm gonna tell you why. Okay. What's gonna happen now, guys? Now I'm shifting P. I'm shifting the pattern. Okay. So every time I shift it. That means after 8 iteration, pattern should be 0, 0, 0, 0, 0. Okay, and I want to repeat. So this pattern, I want to keep repeating this pattern. That's what I told you, right? So what should I do after 8 iterations? After 8 iterations, I have to reinitialize B again. So B should get this value again. Or somehow this P should have. I have to get the initial value back after 8 iterations. Okay. To do that, there are 2 ways to do it. Number one, you can check if P equals 0, if it is 0, 0, 0. So now I can reinitialize it. This is one solution. And I did something different here. Okay, I'm going to tell you it's somehow interesting. I can tell you what I did here. What I did here, guys, is something like that. Okay, you know, something like that. So it is like a rotate, okay, and every bit here has to go to the carry as well, but it's like rotate without carry. And I think we did something like that in last lab. Okay, how you did it? I'm going to tell you how I did it. I did it in 2 steps. Number one, shift. So when I shift, this bit is going to go to the carry. Is that okay? Yes. So this is the first step. Okay. Now, number 2, if the carry is 1, I'm going to write 1 here. And carry is 0, I'm going to write 0 here. That means I'm going to copy the carry to here. You got what I'm saying? So again, guys, what I did is the following. After what I did, I shift. When I shift, this bit has to go to the carry. And then I copied this bit back to here. Okay. What it means? It means after 8 iteration, I'm going to get the same pattern again. You got what I'm saying? Because every time I shift, this bit is going to go to the carry, and then I'm going to copy it back here. Okay. So it's like rotate. It's like I'm doing rotate without carry. I think we did something like that. How I did it here? Show me where in the code you did it. I'm going to show you how. Look here, guys. This is shift. After shift, if the carry is 1, I'm going to come here. If the carry is 0, I'm going to come to here. Okay. Okay. If the carry is 0, I'm going to output 0. Makes sense. Number 2. This is the instruction I'm saying. Okay. Also, I'm going to clear the first bit. Right. So that means if the carry is 0, I have to copy the carry back here. Okay, as you see here. Same thing here, guys. If the carry is clear, I'm gonna do 2 things. Number 1, I have to set the PT0. This is number 1. Number 2, I'm gonna copy the carry, which is 1. So I'm gonna set this bit, which is the first bit. So that means every time I shift this bit, I'm gonna copy it back here. Is that okay? So that after each iteration, I'm gonna get the same pattern again. Any question, guys? Any questions? Social distancing. Any question, guys? Okay. Now I'm gonna teach another program. Here. So also I'm gonna use the LEDs. Okay. So what I wanna do here, guys, I just wanna I wanna like you have the LEDs. So I want to turn the first one on and everyone is off for 1 second. And then I'm going to shift. It's like you shift the LED. And then this one is on and everyone is off. Okay. So, and then this one is on and then this one is on and this is this one. Once this happens, I'm going to come back this way. So LEDs are going to turn them on this way and then I'm going to come back this way and then on this way, on this way. Okay. I want to do something like that. Okay. We want to learn more how can you use Portis. Okay. Let me show you the video first to understand exactly what we want to do before I show the program. Okay. Yeah, chapter 3 programs. Again, guys, I'm gonna you have all these programs, guys. You can, and you have the board. You can connect the board and you can test all these programs. I'm sure they are working. So now I'm gonna show you. So let's run the program. Yes. The delay here is 1 second. For sure, we can, if we change the delay, so it's gonna move faster. Okay, so as I said, you can change the delay so that it can move fast, whatever. Okay. Okay. So now I'm gonna hopefully you understand now what we want to do before I go and start teaching it. Okay. So I'm gonna teach you this program. The good thing, as I told you guys, I'm not gonna teach I don't think I'm gonna teach you any new instructions starting from chapter 3, and this is the most I think if starting from chapter 3, this is the most interesting part in this course. Okay, I'm not going to teach you new instruction. I'm going to use the instruction I taught before just to do some interesting programs. Okay, so let me tell you the idea how I can do something like that. Okay, the idea, the way I'm going to do it, guys, is as you see here in the this is the pattern I want to generate. The pattern. Okay. So here, this is the value I want to output in port B. Remember, 80 is going to be 1 0 0 0 0 0. So this value is going to turn the first one on. This value is going to turn the next one on, which is 0 1 0 0. This is the pattern. So so this is the idea I'm going to do. I'm going to output this pattern or this value on port P. Then I'm going to wait 1 second, and then I'm going to take this one, output this one to port B. Wait 1 second, and so on. Okay, so this one is gonna turn the third one on, and this one is gonna turn next one on, all the way as you see here, guys. This one is gonna turn the first one on. So this is the pattern. Okay, after I turn the first one, so I have to, after 1 it should be 2, because after this one is on, so this one has to be here. You understand what I'm saying, guys? So once it is 40 means it's 0 1 0 0 0. Okay, so I have to come back to 80 again. 80 means 1 0 0 0 0. So what I'm saying, guys, I'm gonna save this pattern in array. I'm gonna call it just a name, LED table, just okay. And all what I'm gonna do, guys, is the following. I'm gonna take, let me erase it here. Oops. Okay. All what I'm gonna do, guys, I'm gonna have like x is a pointer. X should point at 80. Then I'm gonna output 80. Wait 1 second. And then X is gonna be here. So I'm gonna output 40. Wait 1 second. X is here. Output 20. Wait 1 second. And so on. By this way, I can generate the pattern you saw in the videos. Okay. But once I come to here, what should I do? I have X. Once X is here, I have to bring X back to here so that I repeat the pattern. Okay. So this pattern here, guys, is gonna turn the LED all the way this way, and then it's gonna take back to here. Okay. To repeat again, X, after X comes to here, I'm gonna come back to here. Is that okay? So again, the idea is that number one, I'm gonna store the pattern. This is the pattern. This is the value which LED. The value I have to output on port B. Okay, pattern. It's a certain pattern. Okay, so I'm gonna put it in port B. Okay, and then I'm gonna use pointer X so that I can display one by one until the end here. Once I come to the end, I have to come to the beginning again and keep doing it. Is that okay? I'm gonna explain the program, how it works. It's very easy. It's not hard. But also I want you to you can again, I'm gonna look how many times I said it, guys. You already have the board. I wish I hope you already connected the board. It works. You already have the program. This is the program here, guys. You can download it, you can run it, you can also play. How can you play? You can just change this pattern. You can change it, whatever pattern you like. So just change these numbers, you can create different pattern. Okay. Anyway, let's tell you how we're gonna do this program. Okay, number one, guys, this is initialization. Okay, I'm not gonna talk about it. So this is initialization. I'm gonna use the LEDs. You have to initialize the LEDs. Also, you have to disable 7 segment because they also connected to port B. Okay, this is initialization. One time, yes, it is one time. That's okay. Number two, I'm gonna have here infinite loop from here to here. This is infinite loop. That's interesting. Okay, guys, infinite loop. Okay, because I want to keep repeating this pattern forever. That's what I want to do. Okay. Number two. Now I have a table, as you see here. This table should have 14 elements, right? 14 elements. So what I'm gonna do here inside this infinite loop, this part, this is a for loop for 14 iterations. Okay, guys. So this part is gonna be 14 iterations. 14 iterations, that means I'm gonna come all the way from here until the end. Okay, and once I come back to here, I'm gonna start over again. Okay, so I need 14 iteration. I need to make a for loop for 14 iteration. Okay, how can we make a for loop? Okay, that's very easy. I explain different ways to make loops. Here in this program, I decided to use this way. Again, anyway, as long as it works, I'm okay. But here in this program, I decided to use this way. I decided to make a variable byte counter. So this is a counter, okay? And this is a for loop here, guys. Look at the for loop. Let me use different color. Purple, okay. So here, this is the for loop. This one, oops. Okay, and this part here. And this part as well. Okay, so the purple here, this is a for loop. How I made it, guys? You can see here. I'm gonna put initial value in counter 14 because I want to make 14 iterations. Every iteration, I'm gonna decrement counter, this counter. And now, if it is not 0, I'm gonna come back to here. So every iteration, I'm gonna decrement it. If it's not 0, I'm gonna come back. So by this way, I can make a for loop. I'm gonna repeat this part 14 times. Is that okay? Any questions? Okay. Someone can ask me, where is compare? We always use compare. I think I addressed something like that before. But anyway, just to repeat, where is compare? We always use compare. What I can say, if you want to use compare, that's okay. You can use compare. But actually, we don't need it. Why you don't need? Because decrement is going to update the 0 flag. So if the result is 0, decrement is going to make the 0 flag is 1. Anti-branch if not equal is going to look at the 0 flag. So you don't need to set the flags because decrement is going to set the flags. I hear the branch if not equal is going to look only at 1 flag, 0 flag, and decrement is going to set it. So I don't need to use compare. If you want to use it, that's okay, but just I don't need it. Okay. Any question, guys, here? So let me say what you see here in red is infinite loop. Inside the infinite loop, I'm gonna make for loop for 14 times. That's what I did. Is that okay? Okay. So now, what should I do in every iteration? Very easy. What I have to do in every iteration, X, I'm gonna take the value pointed by X. I'm gonna send it to port B. This is number 1. Number 2, I have to increment X. So that next iteration, I'm gonna take the next value. Is that okay? Okay. Number 3, I have to wait 1 second. That's exactly what I did. Look here, guys. Here, I'm gonna take a byte. I'm gonna take the byte pointed by X. I'm gonna send it to port P. Okay. Again, don't be confused. Any instruction I taught for memory location, you can use registers, ports direction register in this instruction. Okay, so don't be confused. This one is going to replace by address, whatever the address number 2 or whatever. Okay, so you actually copy from this location to this location. This is a memory. This part is a memory. This part is a port. Okay, so here I took. I forgot to tell you in the very beginning, X should point here in the very beginning. X should be point at the first location, and then I'm gonna take the location pointed by X. I'm gonna send it to port B, and then I'm gonna increment X. Why you increment X? So that next time I take this one. Next iteration, I'm gonna take this one. Next iteration, I'm gonna take this one, because X is gonna point at different location in every, because every iteration I increment X. Is that okay? Okay, now, and then I'm gonna wait 1 second. Okay, let me clear the mess I made here, and then you can only look. I want you to look. This is the body. I want to look at this part. This is the body of 14 iteration. Okay, I'm gonna take 1 byte, which is 1 pattern from here. Okay, I'm gonna put it in port B. Then I'm gonna increment X, and then I'm gonna wait 1 second, and then I'm gonna keep repeating this part. So in the very beginning, X is here. In iteration number 14, okay, X should be here, and I increment X. Okay. Any questions? So I told you guys. I like read more. Okay, I told you guys this is for loop 14 times, right? So this is for loop for 14 times. These 4 loops are gonna take the values all the way from here until here. Is that okay? Tell me, after 14 iteration, what should I do? I have to come back to here, right? So because I have to repeat, I have to keep repeating it. Okay, how can you do that? What should I do to that? Like reinitialization, how I can do that? Is the way you are gonna do it, guys. After 14 iteration, you are gonna come back to here, right? After 14 iteration, and this is the initialization again. Oh, so how you did the initialization? Number 1, as you see here. So this is the reinitialization. Okay, number 1, as you see here, guys, X, load X. So X was here in the first iteration, X was here. Now I'm gonna bring X to here after 14 iteration, so that I start from here. Okay, what else I have to do? I have to initialize count with 14 to make another 14 loops. Is that okay, guys? So this is for loop for 14 times, right? After 14 iteration, X should be here. Counter loop count CNT, sorry, CNT should equal 0, right? So after 14 iteration, I'm gonna come to here to reinitialize the loop counter to make another 14 and to also reinitialize X. Okay, guys? Any questions? You can ask me if you have any question. Any question, guys? Okay. Now I'm gonna show you how we can do the same thing using C language. Okay, and in C language I'm gonna teach you 2 different programs, 2 different ideas. Okay, I'm gonna start with the idea that is very close or very similar to the assembly. Okay, again, I think I can, if I just wanna, I can teach only one idea, right? Just to make it easy for myself. But I believe in programming it is very useful. You need to learn different ideas. Okay. Because you may need to use this idea in a different program. You need to learn different programming techniques. Anyway, so I'm gonna start with program 2 first, because this program 2 is very similar to the assembly program I have taught right now. Okay, so similar to what I did, guys, I created an array here, as you see, I created, this is the pattern, same thing, but I just use the format of C language, okay? Again, guys, maybe some of you taught or learned C language maybe some time ago. I forgot to tell you, on the course website, I post a review for C language, okay? Some slides for review for C language, okay? You should learn how to make arrays and things like that. You already took this one before. Unfortunately, because we lost several lectures for this Corona crisis, so I don't think I will be able to review the C language. So you already have the slides on the course website. You can read it, and you have any question, as I said, I'm gonna meet you every day. Feel free to ask. This is my job, okay? So if you need any help, even if you need help for something, okay, outside this course, like for example C language, you have learned C language before, but you still, if you need some help, we can help you, okay? Anyway, so this is the program, which is very similar to the structure, okay, or the idea similar to what I took now. So I created array, okay, this way. As you see here, this array has 14 elements, as I said before. The first part here, guys, in initialization. So I have to initialize port B. I have to initialize port J. Okay. I have to enable LEDs. Okay, guys. By the way, I forgot to disable 7 segments. Okay. So if you run this program, you will see the LEDs are working. Also, 7 segments are given like a random, some random segments are turning on. Okay, because I didn't disable the 7 segment. You can add it. Okay, but anyway. So, and this is the program is here. So this part is just initialization. This part here, guys, is just initialization, and the program is here. We have infinite loop. Exactly similar to what I did before, exactly, okay? And then I'm gonna have a loop for 14 times loop, okay? Exactly similar to what I did before, okay? And in every iteration here, I'm gonna do 2 things, okay? I'm gonna read, look here, guys, in the body of 4, I'm gonna do 2 things. Number 1, I can see I here, I should be moved from 0 to 13. Okay, so I'm gonna take the element pointed by I. Here, when I equals 0, I'm gonna take this element, I'm gonna send to port P. Can you see this format, guys? Okay, what this format means? This means this part is gonna be replaced by the element I. So in the first iteration, I is 0, so this part is gonna be replaced by this value. Is that okay? Okay, next iteration, I is 1. Next iteration, I is 2. I is 3. I is 4, and so on, until I is 13. This is 13, guys, because we started from 0. So starting, yes, we have 14 elements, but when you start from 0 to 13, is that okay? So every iteration, I'm gonna take one pattern, I put it in, I send it to port B to turn one LED on. Then I'm gonna wait half a second or whatever the time is. Here I made it half a second. Okay, so I'm gonna wait half a second. If you want to make it 1 millisecond, that's okay. Okay, so what I'm gonna do here, guys, this part here, this is for 14 elements. So I'm gonna take all the elements from here to here. Is that okay? And then when I come back to while again, I'm gonna repeat again from here to here. Okay. Any questions? I know a C is very short. Is an instruction, very compact instruction. We don't write too many instructions. Any question, guys? Interrupt me if you have any question, okay? So this is the first idea. This idea is very similar to what I taught in assembly, okay? I have another idea, which is somehow different, okay? But again, I just want to teach different ideas, okay? Number 1, as you see here, guys, this is the initialization part, okay? I'm going to use 7 segment disable, LED enable, and this is the easy way to do it. Just use these 2. Every time you want to use LEDs, you can just use these 2 instructions. Enable LEDs, disable 7 segments. That's it, okay? This is a good thing about C language. You hide the details, right? Because you just use functions. The details are inside the functions. But in this course, because I'm also teaching assembly, you have to know the details, right? This is major difference between C and assembly. Okay, anyway. So this is just This part is just initialization. Now we have infinite loop here. Infinite loop. This is the beginning of the loop, and this is the end of the loop is here. Okay. Inside this infinite, here I'm not gonna create array. This is the main difference between this idea and the previous idea. Here there is no array, there is no pattern. Okay. So what you are gonna do now? What I'm gonna do here, guys, is that I'm gonna turn. You have LED number 7, you have LED number 6. Number 5 all the way until number 0, right? So I'm gonna turn number 7 and then number 6 and then number for 1 second, right? And so on. So I'm gonna go all the way this way. I'm gonna turn one by one. Okay. Once I come to here, once I come to number 7, so next time I'm gonna come from 1 to 6, and then I repeat again. Let's say how this idea is different from what I did. What I did before, guys. Number 1. I stored the pattern I want to generate in array. And then I took one element one by one and sent it to port B. This is the main idea I did here, okay? Here is a different idea. Here, I'm going to turn LED 7, okay? And then I'm going to turn 6, and then I'm going to turn 5, and so on, until 0. This is, so I'm going to go all the way from 7 to 0. And then when I come back, I'm going to come back from 1 to 6, okay? And then I'm going to repeat again. Hello? Hello, guys, do you hear me?
Yeah.
Okay, sorry, because I got a message the internet is is not stable. Okay, so so far you are okay. You are following me up. You hear me, guys? Okay, great. Thanks. Okay, so this is just a different idea, guys. So I'm gonna from 7 to 0, and then from 1 to 6, and then I'm gonna repeat the same pattern again. Okay, so how I can go from 7 to 0? I'm gonna use 1 4. How can you go from 1 to 6? I'm gonna use another 4. So I'm gonna use 2 4s. 1 for loop to turn LEDs from 7 to 0, and then from 1 to 6, and then I'm gonna repeat again. This is the first 4. So this 4 is gonna take here, it's gonna turn LED from 7 to 0, okay? And from 1 to 6, it's here. So this one is gonna take from 1 to 6. How it works, I'm gonna show you how it works. As you see here, guys, I'm gonna start from number 7 until number 0. Yes, that's what I'm saying here. I want to turn LED number 7 in one iteration. Next iteration, I'm gonna turn number 6 all the way until 0. That's okay. So I'm gonna start from 7. I'm gonna go to until 0. Every iteration, I'm gonna decrement I by 1. See what I did here. I'm gonna turn LED number I. I'm gonna turn LED number I. Okay. I'm gonna turn LED number I on. Okay, so for example, I'm gonna turn the first one on. Okay, then I'm gonna wait some time. Okay, and then I'm gonna turn it off. I'm gonna turn this one off. This okay. So here, this number 7. I'm gonna turn it on. Is that okay? And then I'm gonna turn it off. Okay, and then I'm gonna wait some time if you want. Okay, and then I'm gonna come back. I'm gonna repeat again. Okay, so I'm gonna come to here. Okay, next iteration, I'm gonna work on LED number 6. I'm gonna turn it on for half a second. Okay, and then I'm gonna turn it off. Okay, then I'm gonna wait half a second, and then I'm gonna come to here. Okay, I want you to run it, guys, and see how it works. And I think you may need, if again, it depends on what pattern you want to generate, but maybe you can get rid of this delay. You got what I'm saying? Because with this delay, you are gonna see half a second, and none of the LEDs is on. All the LEDs are off for half a second. Okay. So, but if you delay this one, what's gonna happen is that it's gonna be more. I think it's gonna be more similar to what I did before. Okay, without this delay. You understand what I'm saying, guys? So you're gonna turn on. You are gonna wait some time, and then you turn off. Okay. If you delete this delay, without this delay, when you come back again, I'm gonna turn the next one on. Okay, then I'm gonna so but the way it is right now with this delay, there is some time if all the LEDs are off during this time. You can see it. So again, you can put it, you can delete it, whatever you want. Okay, so so here you want to turn one LED on. You can wait some time to keep it on for some time, and then you turn it off. Okay, and then here I'm gonna turn it off. That means all the LEDs are gonna be off. Okay, if you like it this way, that's okay. If you don't like it, you can cancel this delay. Okay, and then I think if you cancel this delay, this program will be closer or similar to the programs we took before. Okay, so this one here, guys, as I said, is gonna turn LEDs one by one from 7 to LED number 0, from 7 to 0. Okay, next I told you, then I have to come from 1 to 6, and then I have to repeat this again. So this is the first 4, should take it from 7 to 0. Next one here should take us from 1 to 6. Okay, and it's the same thing here, from 1 to 6. Is that okay? Exactly same thing. And then after I finish from 7 to 0 and from 1 to 6, after I finish this one and this one, so I'm gonna come back to while again to repeat again this pattern. Okay, guys, any questions? Okay, guys. Okay. So here, okay. I think this slide is just very easy. I'm not gonna. I don't want to spend time on this one. But I can quickly explain it because nothing is new here, guys. So here I'm saying, if you want to turn one LED on, you can use this instruction, guys, as I said, or you can use this instruction. Okay. Same thing here. You can use this instruction, or you can use this, or you can use OR operation. However, as I told you, this one only work for LEDs, okay? But this format can work for any port. Remember, LEDs are connected to port P, okay? So if you wanna put 1 or 0, if you wanna put 1, so you have to use this one, okay? Now, if you have to use AND if you wanna put 0, so you can use this format to turn one LED off by writing here again. Remember, I turn LED off by writing 0 on the pin. I write 0 on the pin, okay? Or this, okay? Again, you can use this function, this function, or you can use this, just use this instruction, okay? Now, what if I want to flip? If I want to flip one bit, yeah, you can do this way. Port B should equal port B XOR 1. By this way, you are gonna flip the first bit. Okay, so it's, if it is on, you're gonna make it off, you're gonna make it on, and so on. Okay. Here I just summarize the functions I had. So I told LED enable. This one should be used if you wanna use the LEDs. We have LED disable. Okay, when you have to use this one, you have to use this one when I explain how can I use the 7 segment. You know why? Because when I use the 7 segment, I have to disable LEDs. Is that okay? So I have to use this one later. Also, we have LED on. I have LED off. That's what I explained. You have to put here which LED, which one. So you have to put here a number from 0 to 7 to tell me which one you want to turn on, which one you want to turn off. Also, we have here 2 more functions. Okay. For sure, we have this function for a delay. This is easy one. So here, I have also this function, LEDs off. So this function actually is going to turn off all the LEDs. So this function is actually, it's equivalent when I say port B equals 0. Because this one is going to put 0 on port B. Okay, guys. We have another function I didn't teach. I can teach now. This one here, LEDs on. Okay, what this function is different and how this one is different from this one. Okay, I'm gonna tell you. This one has a letter S here. This one doesn't have a letter S. Okay, this is the writing. Okay, but how they are different? It's completely different. This one, you have to write here a number from 0 to 7. Okay, to tell me which, this one should turn only one LED on. And you have to put the number of the LED you want to turn it on. Is that okay? This one is different. This one, actually, whatever you write in is going to go to port B, right? So, for example, whatever is the value you write it here, okay, is going to go to port B. Okay, so this one is actually equivalent to, say, if we want to say port B equal N. and n is actually the value sent it here. Is that okay? So anyway, again, if you are okay, you love this one, it's okay to me. If you want to use this function, it's okay to me. Whatever you want to do is okay to me. Okay, guys? Okay, so now we still have 7 minutes. I'm not gonna follow, for sure I'm gonna teach everything in this chapter, but I wanna teach first the parts I need for labs. Is that okay? So I'm gonna skip this part for now, but certainly I'm gonna come to it. So I'm gonna teach a very interesting topic. I love to teach it, and you will like it too much. So we have a buzzer. We have a buzzer on the board. Okay, this buzzer is connected to only one pin, PT5. Is that okay, guys? So we have a buzzer. This buzzer should generate sounds. And if you go to the YouTube video, YouTube channel of this course, you will see some student did some project on running songs. Okay, they actually use this buzzer to run some songs. I'm gonna tell you how. Okay, so this buzzer is connected to PT5. Okay, so let me show you where you can locate this. This buzzer on the board. I'm gonna go back to show you where. Yeah, this is the board. So this is the buzzer is here. This is a cylinder device is here. Okay. By the way, if you find this if you find this paper, this sticker on the buzzer, take it off, because this is you may not hear it well if you put it there. So take the sticker off. Okay. Anyway, okay, guys. So let me say what I said. Now I'm gonna teach how can you program the buzzer to generate some sounds. Very interesting. I love teaching this part. Okay. So you will like it. So this buzzer, as I told you, is just one pin. The good thing about this in this part, nothing is new. Programming wise, nothing is new. Okay, you will see now. So I'm going to teach almost the same thing, but using different devices. But anyway, okay, guys. So now I told you I have a buzzer. This buzzer can generate some sound. Great. So the first question, or the first thing I need to answer is, how can you generate sound? How can you make sound? Okay, it's very easy. The way you have to make a sound is, all what you have to do here on BT5, just one pin. Okay, you have to generate a square wave. That's it. Yes, that's it. So all what you have to do to generate a sound, just you have to generate a square wave on this bit, in this pin. Nothing is new. That's what I taught multiple times. How can you generate a square wave? That's very easy. Okay. Okay. Now I'm gonna give you more details. Okay. However, there is one important point here. This square wave should be in a certain frequency range, right? So human being can only hear, our ears can only hear a certain range. I think you can check online for sure, but my guess, it's as far as I know, it's between 200 hertz, I guess, until 20 hertz. This is the range of frequencies a human being can hear. We cannot hear frequencies more. We cannot hear frequencies, more or less. So you have to keep. So all what you have to do to run some sound here, guys, you have to generate a square wave here, but you have to keep yourself. You have to keep the frequency here in this range, because this is the range we can hear. Is that okay, guys? Okay, and by changing the frequency, you actually are gonna change the tone. You know what tune means? Okay, so tune, you can generate different tunes by different frequencies. Is that okay? I'm gonna tell you some very interesting stories here. Number one, as we get older, we don't hear higher frequencies, by the way. So as we get older, higher frequencies we cannot hear. So that's why the kids, the little children can hear more frequencies than us. If you search online, you will find some websites. This website can guess your age from the frequency you can hear. So they run a certain frequency and they ask you, do you hear this frequency? Yes or no? And then based on your answer, yes or no, they actually is gonna tell you what's your range of age. Okay. Another interesting thing I read in the news last year, in South Korea, there was some teenagers who meet in a park and make some noise to the people. So they decided decided to use like devices like this one, and they run like some high frequencies only teenager can hear, so that they make a noise, so that teenager can go away. Okay, and also if you there are some devices, it's commercial devices we use so that rates, okay, rates. These rates can hear higher frequencies than us. Okay, so these rates they can once they hear for sure you can run the device, you are not going to hear anything, our ears are not going to hear anything. Okay, so but rates are going to go away because it's going to be like very noisy for them. It's somehow interesting. Okay, so now let me summarize what I said. We have a buzzer. This buzzer is connected to only one bit, PT5. All what you have to do just to generate a square wave. And you already know how to do it, but you have to keep the frequency in this range. Okay, so now I'm going to teach. Oh, still have 1 minute. Okay. Okay, I'm gonna. So in this program, for sure, I don't have time, but I can say something so that when we meet 4:30, I can talk about. So here in this program, I want to generate 2-tone siren. It's going to be like a police siren, 2-tone. Okay, 2-tone. One tone is 250 hertz, the other tone is 500 hertz. Okay, you know the police siren. This police siren has 2 tones, and we alternate the 2 tones. Like in the police siren, it's something like this is one tone, is another tone. So that's exactly what we're going to do in this program. We are going to generate 2 different tones, and we alternate these tones. Okay, so now I think we don't have time. Okay, no, so I think I'm gonna meet you guys 4:30. I'm gonna start from here 4:30. Okay. I'm gonna teach. I'm gonna give a lecture around 1 hour and 20. Then I'm gonna give you some rest, 15 minutes, and then we're gonna have the test. Okay. I'm gonna stay online if you have any question. Okay. Okay. Thanks, guys.
How long will we have to take the quiz or test again?
It's gonna be 1 hour, 1 hour 15, something like that.
Okay.
Okay. Okay. So.
Do we just put the answers for the questions?
Yes, you have to type. You have to type the answers. Yes. After you type the answers, because it's a programming, right? So just type your answers, put it in a PDF file. You can for sure write in a Word, and then you convert to PDF file, and you have to send to us. Don't forget to write your name on the file. Okay, just to make it easy for the TS. So you write your name inside your answer in a sheet. Okay. Also you can name the file with your name. Okay. The TA should grade it and send it back to you.
Do you want it to send it to both the TAs and CCU in it,
yes,
or just one of the TAs?
No, it's better to send it to both.
Okay.
It's better. Okay. If it's optional. If you want to CC me, it's just okay. I'm okay.
Okay.
Okay, guys. Any other questions? Okay. So take rest now, guys. And 4:30, I'm gonna meet you again. Okay. So
I do one quick question.
Sure.
We're using
it doesn't need to be quick. I have nothing to do. So
it is, we are emailing it to their Outlook account, right? Not through iLearn.
Yes. Now for email. Okay. I'm trying to use iLearn because I didn't use it before. Someone told me it's gonna be easier, especially for grading. So I'm still learning it. But for now, just send emails to the 2 TS. Is that okay? For now.
Do you have the emails posted somewhere of what their emails are?
The TS, it's
yes.
in the course website, and also
okay.
I'm gonna send email also to you. Okay, to tell you to remind you with the emails. Okay.
All right. Thank you.
But it's on the course website anyway. Okay.
All right.
Okay, guys. Okay. Any other questions? Okay.
You said it would be just like the quizzes, right?
Yes. Yes. It's gonna be very close to the quizzes. Yes. It's gonna be on chapter 1 and 2. Okay. So bye.